All right, welcome to the second and final video of systems of equations. This time we're going to do some new stuff. All right, so we are going to look at systems that involve quadratic functions now. So there's two possibilities that we're going to really look at this year. The linear quadratic system and the quadratic system. A linear quadratic system means that you'll have a line and a parabola. Let's imagine the graphs here. Okay, a lot of us picture, okay, here's a parabola, and here's a line, and look, they met once, they met twice. So we could have two solutions. But there's other possibilities. Okay, it's possible that your line might be, say, down here, and your parabola is way up there. And now you have no solutions. Okay? And there is a third possibility. It's possible, though really difficult, to do this just right graphically. You can imagine you've got a parabola, and a line, say, intersects only one time with that parabola. Just grazes by, clips it one time only. Okay? By the way, this has a name. This is called the tangent line, and this is where you have one solution. Okay, very special kind of case. Okay, now what about quadratic systems? Well, again, there are going to be three possibilities here. You could have a parabola meets another parabola twice and two solutions. You could have a parabola up here, maybe another one down here. Okay, no solutions. Or for one solution, you could have, say, a parabola here and a parabola there, and if I could draw a little better, they just happen to share the same vertex, and so that's one solution there. So those are the possibilities that we could see when we actually do questions. We could end up with two solutions, zero solutions, or one solution. Okay. Now, we're asked to solve the following systems algebraically and graphically. Okay. Well, let's do this algebraically first. We'll start with that. All right, so doing this algebraically, notice that the y's are already isolated. Okay, so y equals 7 in the second equation, and in the first equation, y equals x squared plus minus 4. Well, I'm going to take this second equation and replace y in the first equation. So I end up with 7 equals x squared minus 4. Okay? That's substitution. You will notice that when you solve algebraically for these kind of systems, you will tend to use substitution, and you won't really use elimination too often in this kind of problem. It's such a nice handy system when you're dealing with linear systems, but it's not as convenient now. Okay, we're going to add 4 to both sides. That gives me 11 equals x squared. Square rooting both sides, you get the plus or minus the square root of 11 equals x. And so we have two solutions to our system. We have to plug this back in, but guess what you're going to get for the value of y? Hey, it's already given. It's 7. So our two solutions, therefore, xy equals positive root 11 comma 7 or negative root 11 comma 7. Okay. I'd like you to pause the video right now and graph both the line and the quadratic and look at what it would look like. Go ahead and pause now. Okay, welcome back from pausing. Roughly speaking, what should your graph look like? Well, let's see. Y equals x squared minus 4 should have looked like this parabola. Okay, and that parabola there, we'll put a little label on it, and we've got to add some information. Well, let's see, your y-intercept should have been exactly at -4, and your x-intercepts at 2 and -2. If you're having trouble graphing parabolas, I suggest you go back to some prior chapters where we did look at this and kind of rebuild and rehone those skills. Now in blue, I'm going to graph y equals 7. Well, it's not a really complex graph. Y equals 7 is a horizontal line. Okay. And graphically, we see there's two intersections. And those intersections take place at y equals 7. It's tough to see exactly where they take place on the x-axis, but it just so happens, we know that because we've done it algebraically, that the 2 points that are visible are root 11, 7 over here, and negative root 11, 7 over there. Okay, second example to try here. We're going to solve this both algebraically and graphically. Okay, again, algebraically, I have y already isolated in, say, the second equation, and I will substitute this minus x minus 3 in place of y in the first equation. So we get minus x minus 3 equals x squared plus 6x plus 7. I'll move everything over to the right side here. So I have 0 equals x squared plus 6x plus x, 7x plus 7 plus 3, 10. Oh, I can factor that. I get 0 equals x plus 2, x plus 5. Therefore, the two solutions are x equals -2 and x equals -5. Okay, well, I'm not done yet. My conclusion is going to say x, y equals, and I'll have -2 comma something, and -5 comma something else. How do I get those y values? Well, it's actually a lot simpler than it looks. I just take the x value and plug it back into one of the two equations. So for example, if you plug x equals -2 into the second equation, you get y equals -2 minus 3. That's plus 2 minus 3. That is -1. In the second equation, if you plug in -5 into the second equation, let's see, I believe you get +2. Okay. Graphically, I'd like to again invite you to practice your graphing skills right now. And when you're done graphing this line in this parabola, you will know that you are correct because the parabola and the line should meet at these 2 points exactly. If you're not getting them to meet at those 2 points exactly, come talk to me. We're going to be able to work this out together. Okay, another example here. This is a quadratic system. So I have one quadratic here and one quadratic here. This time I think I will graph these, and I'm going to be kind of quick with my graphing, since I'm going to assume, again, we have some familiarity with graphing now, that we've been working on it for some time in the course. The first parabola, I'll do that one in black. That's y equals x squared plus 2. It looks something roughly like this, where the y-intercept is 2, and it opens up, and there's no x-intercepts. Okay. Second one in red, y equals -x squared plus 2x minus plus 6. What is the -x squared telling you? That's right, that negative sign out front is telling you this is going to open down. What's the 6 telling you? That's the y-intercept. So the y-intercept is at 1, 2, 3, 4, 5, 6. And we're going to open down. Okay. Where's the vertex located? Well, the vertex is negative b over 2a. And so the x value of the vertex is negative 2 over 2 times negative 1, which is 1. So the vertex is 1, comma, well, plug 1 into the formula. And let's see, that's minus 1, plus 2, plus 6, 7. So there's a vertex at 1, comma 7. Okay, so let's see, what is this going to look like? Well, it's going to look something like that. Hey, where are the X-intercepts? How do I find those? Well, I'd have to try to factor here. To find the factors here, we're going to have a bit of a problem. So how can I proceed to find the X-intercepts? Well, you may recall this. X is going to equal minus b plus or minus the square root of b squared minus 4ac over 2a. Of course you have that one memorized, right? Okay, so let's see. I was joking, by the way. X equals minus b, so that's minus 2, plus or minus the square root of b squared is 4, minus 4ac, so that's plus 4 times 1 times 6 plus 24, all divided by negative 2. 2 times negative 1 is negative 2. And so that gives me x equals negative 2 plus or minus the square root of 28 over negative 2. And so that gives me x equals negative 2 plus or minus 2 root 7 over negative 2. And in fact, dividing by negative 2, I get 1 plus or minus root 7. Okay, well, those are numbers. If you want to have an approximate decimal representation for those numbers, go ahead and type that into your calculator. 1 plus root 7? Yeah, that's a little short of 4. 1 minus root 7? Well, that's negative 1 point something. Okay, well, those are values. They're somewhere on the number line. Why don't you plot them exactly? And in the end, you'll notice we have two solutions to our system. But here I want to stress the limitation of graphing. If you are not using a graphing calculator, how are you going to really find these points here? You're going to need some extreme precision in your graph, and you're going to need some extreme guesswork in order to know exactly where those are. So, yeah, we've graphed. That was nice. But what I want you to really do here is take a moment now to solve this algebraically. Okay? Try that out and see if you get things that match what you see on the graph. See if you get things that, suggest that the graph is correct. And bring that to class so we can discuss it together. Okay, and then what's left here in this section is practice for you to do. So I've got 1, 2 practice page, and a third practice over here on this page. And afterwards, well, there's a huge list of homework because actually you just finished all of chapter 9. That was quick. Or chapter 8. Is this chapter 8? Oh, this is chapter 8. You just finished all of chapter 8. Wow, this is quick. Okay, I'm going to quit while I'm not as far behind.